Hello everyone, and welcome to our webinar with Saft, where we'll be looking at the changing scope of digitalisation for the successful operation of energy storage assets. I'm Andy Colthorpe, editor of Energy Storage News. Batteries were described by one industry source I interviewed a while ago as the first truly digital asset for the electricity grid. Their flexibility in being able to store or discharge power is enabled by a high level of control and monitoring that digital technologies enable. Meanwhile, the huge amount of data that can be captured and used to refine system-level decision-making is what makes batteries a truly versatile part of the energy system toolkit. Digital technologies also enable batteries to interact with other resources, from solar and wind to thermal power plants and transmission and distribution infrastructure. A 2019 survey of nearly 2,000 energy industry professionals by DNV found that more than half of respondents in the energy storage sector felt digitalization can improve operational efficiency, while around 40% said it can improve decision-making and assist in innovation. Today, we'll be hearing about all of those things from the perspectives of operating energy storage assets to their optimal value and longest and most useful lifetime. A newer report from Bloomberg NEF identified that lithium-ion battery pack prices on average could be cheaper than $100 per kilowatt hour by as early as 2024. But without the digital technologies of the type our speakers will be talking about today, batteries and renewables won't be able to compete and play their vital role in decarbonising and modernising the global energy system. Joining us today from Saft are Michael Lippert, who is Director of Innovations and Solutions for Energy, digital software developer Stefan Alamo, ESS Product Manager Arnaud Guillaume Deloze, and Carlos Hein, who is Director of Global Services. Each of them will talk us through a different aspect of this exciting field, and we will also be joined in a short pre-recorded presentation by Kristen Schumann. Kristen is Deputy Manager of the Energy Storage System team at TotalEnergies, and her team has been applying Saft's technology solutions and will discuss how they work in a real-world setting. As always, interaction with you, our audience, is very important to us. So please put your questions for the speakers in the tab on the right-hand side of your screen, and we will do our best to answer as many as possible in the Q&A session at the end that follows presentations. Now, before we get started, here's a quick poll that you can all take part in. And this could be something just to break the ice, but I think it will also give us an interesting insight into your different levels of engagement really so far with this topic. So the question is, what are the main challenges to capturing the full potential of digitalization for energy storage systems? Now, to respond to the poll, there's a poll tab again on the right-hand side of your screen next to questions. So please input your answers in there, and you can see the results there as well as we go. And your options are data, cybersecurity, finding the right software provider, having the right operating data platform, or interoperability. So once again, what are the main challenges to capturing the full potential of digitalization for energy storage systems? Is it data, cybersecurity, finding the right software provider, the operating data platform, or interoperability? And as I say, we'll be revisiting that poll and its results a little bit later on. So after that, without further ado, over to our first speaker, Michael Lippert from Saft. Michael, the floor is yours.
Yes, thank you very much, Andrew, for this introduction. Hello, everybody, and thank you for joining us today in our third webinar on ESS. My name is Michael Lippert, and I'm very happy to talk to you today about the value digitalization can bring to operators of ESS. Seen from the perspective of a developer, manufacturer, and integrator of lithium-ion batteries like Saft. So, what have we prepared for you today? Why should ESS go digital? We will look at some of the concerns operators may want to address, first from a general point of view, followed by a real-world example with one of our customers. We will then share our 3 main ideas on how to make best use of digitalization and talk about the benefits we see for developers and operators. My colleagues, Stefan and Arnaud, will develop these aspects in more details, talking about data infrastructure and digital functionalities. Finally, Carlos will show us a practical use case on an existing ESS installation, illustrating the benefit of real data in operation. Before we start, a word on Saft. Well, what we do is batteries. Since 100 years, we develop, manufacture, and install advanced batteries for industries. With 4,000 people and 16 industrial sites worldwide, our batteries power devices at space, in the air, on land, and at sea. ESS energy storage systems is one of our younger activities since about 10 years now. Here, we build complete turnkey lithium-ion energy storage systems for applications ranging from solar and wind energy shifting, as you can see here on the picture, through different types of microgrids to short-term auxiliary services and other grid support functions. For the battery system, we build the energy storage units, which you see here in containerized versions, and we then integrate power conversion, transformers, and the power management system around the battery, including, and now I come to the digital layer, our own data management solution. So today, we look at the digital functionalities within the perimeter of the ESS system, which means we do not consider the operation of dispatch optimization or digital bidding platforms and the like. Luckily, the multiple building blocks of an ESS do produce continuously a whole wealth of data. So what we want to share with you is how to make best use of this data for the benefit of the storage system operator. So let's start. Why should ESS go digital? Well, some general thoughts. The first and most obvious issue is linked to the distance and time needed to access usually unmanned sites. I have illustrated this with a 14 megawatt system which we installed in a gold mine middle of nowhere in Western Australia. It is clear that operators need to access information remotely in order to avoid traveling, save time in resolving issues, and gain reactivity and effectiveness. Secondly, a real headache to operators is to appreciate the state of health of a battery system. We know that aging is directly depending on the usage of the battery, with multiple factors such as the frequency and depth of discharge of cycles, temperature, power rates, state of charge, and so on. Furthermore, battery health cannot be condensed into one single indicator to know whether things go well or not. Remaining lifetime, available performance, and safety, they depend on a sum of parameters. These include residual capacity, but also internal resistance and other factors. And finally, well, the aging behavior is specific to each manufacturer's cell technology and chemistry, as well as the chosen architecture. Now, well, we cannot send the battery to the doctor for a regular health check as you would do for yourselves. It is clear that collecting and computing very precisely all operation data on the one hand and battery data is crucial. Ideally, we would be able to do this health check, a kind of test routine, from a distance. And this would then allow us to prevent or at least anticipate any failures, to optimize the lifetime, and to make informed decisions. For example, to know the impact of changing operation patterns on the battery life. My last point has to do with flexibility, a topic we dealt with more in detail during our first webinar. We do know that a battery will not operate in a single predefined duty cycle throughout its lifetime. Operators do need to adapt the operation pattern to changing market conditions and rules. And hopefully, they want to capture new revenue potential as new services emerge. For example, ESS may serve existing markets like solar shifting or primary frequency regulation as a starting point, but be used for grid infrastructure support, secondary frequency regulation, or later on in the future, even synthetic inertia in the future, when such services mature and allow batteries to generate revenue. This needs, of course, an adapted hardware and software design architecture. But how do we know whether a given ESS is able to take an additional job, for example? How to manage technical and contractual parameters and guarantees that were initially defined for a given product and a given utilization? Well, we believe that with digital tools, we will be able to assess the feasibility of new or additional duties and simulate the limits of our existing installation. Later on, we may want to adapt technical set points remotely, automatically, and even adapt contractual engagements such as guarantees. Well, with these rather high-level views, I'm now very happy to leave the floor to Kristin Schumann from TotalEnergies, our client. She will illustrate the need for digital tools with the example of Europe's largest battery ESS for ancillary services, which is installed in Dunkirk. As Kristin was not able to join us live today, we have recorded her message. And here we go.
Hi, my name is Kristin Schumann. I am the Deputy Director of the Energy Storage Solutions team of TotalEnergies, and I am very glad to be here with you today. The ESS team is a small team of battery system developers based in Paris. We are currently active in France, Belgium, Spain, the UK, South Africa, and the US. Today, I would like to present a concrete case from France, where we have worked with Saft for battery conception, integration, and now for operation and monitoring. In 2020, our team was attributed 103 megawatt in the long-term capacity tender for the French transmission system operator RTE. To provide these, TotalEnergies is currently finalizing the construction of 4 sites in metropolitan France, with a total installed capacity of 103 megawatt. As you see on the map, Dunkirk 1 and 2, with a total capacity of 61 megawatt, are now in operation. Carlin, with 25 megawatt, is located at the German border, and we will be commissioning in the early days of 2022. A final project in Grand Prix will also be finalized in 2022, and we will have a total capacity of 43 megawatt. All these projects are located on French refineries by TotalEnergies. They benefit from existing land and grid connections and local operational expertise. These projects provide 2 services for RTE, a combination of capacity market services and ancillary services, mainly primary frequency regulation. The picture on the left shows Dunkirk 1, when it was being commissioned. As you see on the next slide, TotalEnergies is the project developer, but we work with Saft batteries and infrastructure for these projects. Omexom does the on-site construction. The trading division of TotalEnergies serves as the aggregator for the system and is in direct contact with the TSO. As these projects are connected directly to the French national grid, and by their sheer size and capacity, we have strict availability requirements. We must be available 24/7, and data must be sent every 10 seconds. On the right, I have listed some of the 25 system information, which we store and send to RTE every 10 seconds. These include voltage, frequency, and reactive power. We also monitor battery system health, such as state of charge, depth of discharge, system temperature, and battery aging. For us, it is very important that system operation is fully automated and requires very little human monitoring and bit preparation. For the data monitoring and later analysis and reporting, it is also important that the collected data are reliable and secure. High-resolution data must be safely stored in a data center that we trust. With Saft, TotalEnergies is very happy to have a strong in-house battery provider and partner that we can trust and work with for reliable batteries, IT platforms, and services. With this, I hand back over to Michael Lippert.
Yes, so thank you, Kristin, even from a distance. Now, before we go more into the technical details, there are first three main points we would want you to take away from this webinar. In order to create a useful, valuable data platform, you first need to have a consistent, cyber-secure data acquisition and management infrastructure. Secondly, the functions, a combination of data and different battery models, need to be developed in close cooperation with operators on the one hand. Operators, I mean the people who are managing and supervising the charge and discharge operation of the device, and with the service personnel on the other hand, those who are in charge of keeping the system in operational condition. Finally, whatever you do should be future-proof, of course. On the first point, data infrastructure, there are multiple parameters to be taken into account, such as the nature of the data. What kind of data do you want or do you need to collect? The hierarchy of this data, are we talking about cell level, module level, string level, system level, all of them? The time granularity, do we acquire data in seconds, 5 seconds, minutes, hours? Things like bidirectionality, cybersecurity, and international standards need to be taken into account. By doing this, we ensure operators can generate in a reliable manner, accurate and high-quality information for their operations. When it comes to the functionalities, it is clear that operations and services have different needs of information. Some of them, such as real-time dashboard or historical data, are equally useful to both. Others, like configuration management or alarms, are more specific to services, whereas health and in particular performance measures are critical for operations. The goal and benefit here is to ensure that information we produce matches the precise needs of operators and services and helps them to best manage aspects like availability, but also performance compliance, OPEX, or safety. In order to anticipate evolutions in the future, well, in terms of parameters, we again have to look at things like the data infrastructure, the nature and quality of the data collected, the flexibility of the platform, and also the data storage capacity. But also, we need to look at the different battery chemistry, system, and thermal models, which can, by the way, evolve. And finally, we should take into account return on experience from the field. The goal here is not only to be prepared for changing ESS system configurations and usages in the future, but also to anticipate the development of new analytical, predictive, and automation functions in the future. Well, with this, I hand it back to Andy, because I think we have another poll, and maybe you can share the results of our first poll first with us.
Indeed we do, Michael. Thank you very much. Yeah, absolutely, absolutely. So we did ask earlier on, what are the main challenges to capturing the full potential of digitalization for ESS? And actually where you responded, where about half of you responded to this, you can see the results as well in the right-hand side tab where you voted, but I'll also read them out just quickly for you. So in the lead, the biggest challenge, as identified here, was data, and 28%, so nearly a third of you said data was the main challenge. Interoperability was at 21% or 22%. The results are changing sort of in real time as we speak, but about a fifth said interoperability. And then it was evenly split in third place between cybersecurity and the right operating data platform. So around 17 or 18% of you said that. And finally, finding the right software provider appeared to be the least of your worries at this point, with only 12%. So what's really interesting is that we held an earlier session for the benefit of folks in Europe and in that time zone and earlier on, and the interoperability issue was actually first there, with data in second and cybersecurity a little bit lower down in the priority order. Anyway, so moving to the second poll, which we'll visit again a bit later on. So this one is less about the challenges and more about the value. So in which domain would digitalization create most value for you and for your business? The options you have there are, and just to bear in mind, you don't click on the icons on your screen. You click in the poll on the right-hand side. Real-time monitoring, managing performance KPIs, optimizing maintenance, optimizing OpEx, or longer system lifetime. So which domain would digitalization create most value for you and your business? Is it real-time monitoring, managing performance KPIs, optimizing maintenance, optimizing OpEx, or longer system lifetime? And we look forward to hearing your thoughts on that over the next few minutes. So with that, we'd like to hand over to Saft's, or one of Saft's software experts, Stéphane Alamo. Hi, Stéphane.
Hi, Andy, and good morning or good afternoon, everyone. I will focus on 3 key requirements highlighted by Michael, and for each of them, I will explain what are the technical challenges and how Saft solved these challenges. So, the 3 challenges are: 1, how to build a high-quality database solution, and we will see how important it is to have a tightly integrated end-to-end data pipeline. 2, how to build a flexible and scalable solution, and we will see how your company can profit from the modern cloud and big data ecosystems. 3, how to build a secure solution, and we will see the importance of having a security referential and secure development process. So first topic, data quality. Why is data quality so important? Because it is like the foundation of a building. If the foundation fails, everything falls apart. If you ingest garbage data in, you will get garbage analytics out. And at the end of the day, your company will take bad decisions and make wrong actions on your ESS system. So you must be able to trust your data. Usually, we highlight 5 key characteristics we want to achieve in terms of data quality. In a nutshell, your data must reflect your physical system with the right fidelity at the right time all along the data path or data pipeline, and it must be tailored to the information you want to extract from the raw data. So let's see how. A classical data pipeline is made of several layers. In the acquisition layer, we collect the metrics from the batteries, the PCS, the MBPS, the PMS, the watt meter at POC, etc. Because for Saft, we are a full scope provider. And for the battery, the main source of data is the BMS. So data quality starts at the BMS. And at Saft, we have designed our own BMS hardware and software solution, allowing us to fine-tune the data acquisition process to get the right data at the right time. We have full control over the numbers of metrics, their resolution, their frequency, etc. And in terms of completeness, we are catching more than 1,200 data points per battery container, down to 1 second period, and it covers all levels of the battery hierarchy: bank, strings, modules, and extreme values of the cells. It also includes data for auxiliaries like HVAC, door position, fire suppression system, etc. And this kind of data is very valuable to optimize the maintenance of these auxiliaries. Then the data is transmitted with the transport layer. Of course, this layer must guarantee the security and the integrity of the data. And then it is ingested in the cloud that hosts the storage and the analytics layers. In the storage analytics layers, we build our own in-house analytics engine, and we keep the raw data in a long-term cost-efficient storage, allowing us to revert to the original data in 2, 3, 10 years if needed. Then comes the visualization layer. This is another important aspect of the data quality. It should be useful. Here, the key point is to find a way to present the data in a meaningful way for the end users, for people who are not data scientists, who are business specialists. And we achieve this by conducting specific user experience, UX, and user interface, UI, design studies with the end users to create the right and the most efficient dashboard. In conclusion, we saw that data quality is critical all along the data chain, and that it is better to implement in-house solutions at some of the critical layers and to integrate them all together tightly to have a full control over the data quality. You also need your platform to be future-proof. And the first pain point that you need to address is the exponential growth of the data. As the ESS market will continue to grow by 2-digit figures every year in the coming years, the accumulated mass of data will become massive in the petabyte scale. To handle this, you need to go cloud native and you need to embrace big data technologies. Services provided by cloud platforms are today ridiculously easy to scale up, and there is basically no limit. The two other advantages of being cloud native is that one, you will profit from the high availability of the cloud services. The vendors commits to a contractual SLA, typically in the range of 99.98%. And secondly, you will profit from the multiple geographical regions of the cloud providers to offer the same performance all around the globe and to get geographical redundancy. To be able to add new functionalities and new service in your platform, and also to easily maintain the one already released, you may want to prefer de facto and open standards and avoid proprietary solutions. So more and more we are using standards coming from the internet world, but there are also some open standards specific to our industry, the ESS industry, and I'm speaking about SunSpec MESA. So the MESA standardizes the interfaces between all equipments in an ESS installation. And at Saft, we are big enthusiasts of the SunSpec MESA. If you are a PCS vendor or PMS or solar panel or battery manufacturer, I strongly encourage you to seriously consider the compatibility with the MESA. This will increase the interoperability in our industry. And basically, it means that you can plug any MESA compliant PCS with any MESA compliant battery, and it will work together automatically. And of course, your software development and maintenance strategy should apply all the best practice coming from the Agile and DevOps domain. So continuous integration, continuous deployment, automation, monitoring, etc. So that you are able to deliver a new version every few weeks. All this will allow you to have a platform working and evolving smoothly during the long period of lifetime of the installation. We are talking about 15 or even 20 years. in a very smooth way. So my third and last topic will be security. In a recent study from security firm Dragos, 63% of the US-based organizations had an industrial cybersecurity incident in the past 2 years, and this number is growing every year. Sorry. So I think and I hope that today all of you are aware of this kind of risks. ESS systems are now an essential part of the power grid, sorry, making them potential targets for cyber attacks. And moreover, an ESS digital platform is a hybrid system. It's like having one leg in the IT world and one leg in the OT for operational and industrial world. Sorry. The threats are not the same and the priorities are not the same. In the IT world, the focus is more on the confidentiality, while in the OT, the availability comes first. So for example, our customer, ESS operator, want at the same time that its data stay confidential and that the physical system stay operational. And moreover, in an ESS installation, there are some safety critical subsystems. Obviously, they must be protected. So our approach, we decided to take the EEC 62443 as the main baseline for our ESS digital cybersecurity framework. It is quite complete because it covers the 3 pillars of the security: the organizational aspects, the process aspects, and the technical countermeasures. Here you see a few examples of what topic is covered for each group. But to summarize, the ultimate goal is that 1, the security becomes deeply integrated in your company organization. 2, your technical countermeasure follow a defense in-depth approach. So it means using coordinated multi-layer security measure, like in a medieval castle. And 3, secure by design means that security must be taken into account all along the whole development cycle. In the next slide, you see a typical development life cycle from requirement specification, where we do threat and risk analysis, to design, to implementation, and then in the test and deployment phase. So one major step would be the third-party penetration testing, etc. As you can see, all steps are impacted by the security measures. Thank you for your attention. We will now go on with Arnaud Guillem to talk about the digital twin roadmap. Thanks.
Thank you, Stefan, and hello, everyone. So I am Arnaud, and I'm glad to be with you during this session. So today I will talk about how to build a functional ESS digital roadmap, creating value for the operators and the maintenance team of the ESS. I will start with 2 questions. The first, what are the principles to build a digital functional roadmap for ESS? In our views, there are 4 key principles to apply to build such roadmap. First of all, the function to develop have to be prioritized based on the value they bring to the users. Second, the user interface of the digital solution has to be simple, because users might not be data scientist expert, but more business specialist. Third, all functions cannot be developed at the same time. So the roadmap has to be iterative and step by step. And finally, the user's needs might change time to time based on their experience and feedback. So the function developed has to be ready for new evolutions and capabilities. My second question is, what is a digital twin for ESS and how it can be valuable? Well, a digital twin can be defined as a software platform representing a physical asset. It is built by integrating into physical and predictive model various types of data. such as real-time or historical, operational, and maintenance data, performance guarantees, boundaries data, product design data, or testing lab data. In the case of an ESS, a digital twin is designed to collect data of all the equipment of the installation, starting from the battery blocks to the power converters up to the point of connections, in order to monitor, to predict, and to optimize the usage of the ESS. So now let's move to our vision of an ESS digital roadmap. With the team, we have identified 4 key steps, and I will present you their main functions and benefits for the operators and the service teams. So let's start with the first step, which is about data management and monitoring. Here the functions are to view in real time and on single dashboard, as you can see on the right, the operational parameters of the ESS, such as the power, the state of charge, or the voltage of the installation. For instance, I can check the available power of a battery string or a container, or even the entire site. The other functions is to have access to a detailed level of historical data in order to solve technical issues and to understand the root cause. For example, I can check the historical parameters of the HVAC of a container to solve a given fault. And the last function here is to be able to manage the alarms that can occur during the operations. This includes alarms related to safety in order to prevent any major incident. The benefits for the users are 3. To avoid unnecessary travels by understanding what is happening in real time at the ESS, to save time and increase the availability of the system, and finally, to raise the reactivity of the service teams. So now let's move to our second step, focusing on computing the key performance indicators of the ESS. Here the functions are to remotely view on a single dashboard, as you can see on the right, the key parameters of the performance guarantee, such as the energy throughput, system availability, and the round trip efficiency of the entire DC plus AC ESS. For instance, I can compare the yearly energy throughput contracted between the operators and the service providers with the actual value measured for a given year. And I can be alerted if a deviation is anticipated or happen to correct it and act it quickly. The other main function here is to perform remotely the annual energy and round trip efficiency performance test to avoid travel. In terms of benefits, the functions of our second steps help the user to automatize the calculation of the KPIs indicators, to early identify and correct any potential performance guarantee deviation, and to ensure the operators is using its ESS within the performance guarantee boundaries. Okay, so now let's move to our third step regarding predictive functions. In fact, those predictive functions are being able to develop when enough data are available to train the predictive models of the digital twin. The functions here are to be able to predict the future state of health of the ESS under various types of application patterns, while updating easily the contractual guarantees. For example, when an operator wants to change after several years the usage pattern of its ESS, this function provides him the new set of health prediction with an upgraded contractual performance guarantee from its service contractor. Those predictive functions also help to properly define when to do the augmentation scheme to meet the energy and power capacity of the ESS. Benefits here for the users and operators are to enable the operators to change easily its ESS usage patterns to capture new market opportunities while keeping a performance guarantee from the service team. And the second key benefit is to optimize the augmentation schedule to meet the requirement of the ESS. Last but not least, the function of our 4 steps how to automatize the previous steps described to you for a fleet of multiple ESS sites. The main functions are to automatize and aggregate the performance indicator not at the site but at the fleet level, to set up the maintenance planning based on the usage of the entire fleet, and to set up also and optimize the operating parameters such as maximum power, state of charge window, or temperature based on the usage of the fleet. Benefits for the users, both operators and service, are to optimize the preventive maintenance schedule and cost, to increase the overall availability of the fleet, and finally, to extend the battery health for the operators. So thanks for listening. And now I hand it over to Carlos for an interesting use case demonstration.
Hey, thank you, Arnaud. And good day, everyone. This is Carlos Hein, and I am here to share with you a real use case of how Saft's ESS digital capabilities allow us and our customers to detect, diagnose, and resolve operational and maintenance issues remotely in relatively quick fashion. And so the following example pertains to an issue related to a battery system power limitation or availability at one of our installations in Europe. And for background purposes, the application is utility scale battery storage for grid services. In September of 2021, our monitoring system alerted us of a power limitation, as it can be seen in the dashboard. The overall battery system power should be 20 megawatt with 20 megawatt hour of usable energy. However, the measured usable power at the storage facility had dropped by 0.5 megawatt. And that corresponds to power availability of about 97.5%. So in diagnosing the issue, the monitoring system flagged 4 out of 10 battery systems that are installed at the site with a state of charge calibration required alert. The live status screens identified the affected battery systems at the site with SOC variance across the minimum and max of about 50%. So further data analyses at each bank level identified that 2 out of 9 battery strings with a SOC variance confirming the calibration alert. And now this SOC calibration flag means that the value of the state of charge and the available energy communicated to the energy management system might be the incorrect one. And that is what created this issue. So in order to recalibrate the state of charge, the affected battery banks needed to be isolated. So Saft worked with our customer to establish a 15-minute break of the battery systems requiring this recalibration. And during this time, the system ran a self state of charge calibration routine that allowed the strings to achieve desired state of charge, as it can be seen in the trend here. So at this point, the state of charge calibration alarm was resolved. The available power came back to 100% or 20 megawatt, and the system was reconnected for normal service and dispatched to man. Now, the total remote time to troubleshoot and restore the power availability took less than 2 hours. And this didn't have an impact on the day ahead bidding process. Now, without this remote capability, we estimate it would have taken more than 24 hours to resolve the situation, and most likely have impacted the power level bidding process. Now, the reason that led the battery strings to be out of calibration in this case was continuous operation of the battery and cycling the battery with no dedicated time to for a recalibration scenario that is required in the operations manual. Now, as described in the manual, the short routine should be carried out during the low or no best demand periods to avoid the power limitation that was highlighted here. Now, in conclusion, and thanks to Saft's online digital monitoring system, our customer was able to resolve the power availability issue rather quickly with just a few remote actions. And furthermore, the system uncovered process improvement opportunities to prevent the scenario from reoccurring in the future. So with that, I am going to hand it back to Michael for some closing remarks. Thank you.
Amazing. Thank you very much, Carlos, and also thanks to Stefan and Arnaud for their very interesting, I believe, insights. So, dear audience, in order to conclude, I hope after this demonstration you agree with me that digitalization for an energy storage system is not simply the cherry on the cake. I mean, the kind of device you add on top of an existing system at the end of its development cycle. What we try to demonstrate is the benefit of a holistic approach. As you know, we provide complete ESS systems, including DC and AC components and controls. And we by now also understand that a single container or a single PCS is in reality itself a complex system, including strings, fire suppression system, HVAC, and controls, all of them generating a whole lot of valuable data. At Saft, we have developed the entire system by ourselves, starting on the DC side, the heart of the system, which is the lithium-ion battery, where we integrate cells and modules into standard certified container building blocks. And we know also that the batteries themselves can be of NMC or LFP iron phosphate technology, each of them having its specific characteristics, behavior, and management logic. This is why we have developed our own battery aging models, our own chemistry-specific balancing strategies and control algorithms. On the AC side, then, we add power conversion and power management devices around the lithium-ion battery up to full turnkey installations. So what I want to say is we do the system, including hardware and software from A to Z, knowing in addition that our R&I reaches from fundamental research through technology development up to LCA and end-of-life solutions. Likewise, the digital solution we offer is natively embedded in this development process, as shown by Stefan. Our data platform provides high-quality data of all relevant component groups of the system, including auxiliaries. It carries our battery models, which means models developed by an expert in electrochemistry. It enables flexible and future-proof usage of these data and ensures highest levels of security. This enables us to make a real digital twin because it represents and integrates precisely all design concepts, controls, and models of the system we have developed. Therefore, when it comes to the use side, this digital twin allows to monitor, but also to predict and to optimize a number of key functions for both operations and for services. Those include the very critical aspect of battery health and battery lifetime. We all agree on this, but they also aim to enhance availability, to manage performance, optimize maintenance, and support and witness safe operations at all times. So our ultimate vision of a digital twin is therefore to keep the battery at good health at all times, with best performance and longest possible lifetime, and do it all this whilst keeping the battery usage flexible for the operator, allowing him to generate best return on investment of his asset. So these are my final thoughts on this. I now hand it back to Andy, who will give us some feedback on the polls, and then we go into some Q&A. Back to you, Andy.
Terrific. Thank you very much, Michael, and thanks to your team of experts there for their insights. And I'm sure that, you know, anyone who's interested to know more can find out more through Saft's website, and you'll be able to view the slides again. That's saftbatteries.com. You'll be able to view the slides again and the recordings shortly, either through our website, or you'll be receiving an email with details on how to do that. So back to poll number 2 very briefly. We asked you in which domain digitalization would create the most value for you and your business. And from the answers, we can see that our US time zone audience is in a similar place to our European one in this respect, because real-time monitoring was the #1 answer in both sessions. So 28% of you, 28% said real-time monitoring creates the most value. In second place was managing performance KPIs with 22%. Third place was optimizing maintenance, but only slightly ahead of longer system lifetime. So 18% said optimizing maintenance creates the most value. 17% said longer system lifetime. I guess the two topics are fairly well related. And just a couple of percentage points behind that, with 15% was optimizing OPEX creates the most value for you and for your business. So just about to go to some Q&A questions. Only a few minutes left, but just briefly, if you've got time, folks, we have a final poll for you. So you've seen the presentations from Saft, you've heard from their experts, you may know of them already. Would you trust in the information provided by a Saft digital platform? And you can reply, yes, I trust the quality of Saft's data and algorithms. You could say, no, I would prefer a third-party provider. Or third option would be, I don't know, and I'd need to know more before I can decide. So would you trust the information provided by Saft digital platform? It would be yes, I trust the quality of Saft data and algorithms. No, I would prefer a third-party provider. Or finally, don't know and would need more information before making that decision. So we'll see if we've got time to talk about those polls a bit later on. But with that, welcome our speakers back onto the virtual stage. Hi, everybody. Thank you for your presentations. And we've got lots of questions come in, so absolutely impossible to answer all of them, but we'll start with a fairly simple one, I guess, that you guys would probably want to get across as the sponsors of this one, but I promise it wasn't a Saft employee who asked it. So Balaji G asked, what is the markets Saft is providing products in? So I think we could talk about what regional markets, as well as the sort of availability of which platforms. And Michael, as our lead speaker, do you want to start off with that?
Yes, thank you for the question. I mean, a little bit of background. Saft is a 100-year-old battery specialist. So we do, as a company, and with the 4,000 employees we have worldwide, out of about 18 industrial sites worldwide, we serve different industries from space to the air, on land and on sea. So it's a relatively large scope. Now, my activity and what we are talking about today is ESS, so energy storage systems, an activity we follow since about 10 years for now. And in this very area, and now I try to focus my answer on this question, we offer lithium-ion based energy storage systems. We install them, geographically speaking, on all 5 continents, and we have systems operating in all areas. We have 3 hubs, I mean industrial and project hubs in the US, in Europe, and in Asia, from where we serve our customers ahead of projects and during projects and in execution. And for when it comes to the applications, we install, say, 2 to 4 hour systems for PV or wind shifting. That's the capacity markets also right now. This is the majority of the projects and in the pipeline today, with the very large projects and systems, you know. Now we continue to install also systems that are more in smoothing or ramp control of renewable schemes, in particular wind. We have a couple of microgrids, small microgrids up to very large microgrids. So here we support the variable generation and the support of wind and diesel and solar with spinning reserves to make that optimum and stable. And of course, in particular in Europe, we have in majority today ancillary services markets, such as the one illustrated by Kirsten in Dunkirk. So it's frequency containment reserves today, looking for secondary reserves and others to come. And a more recent and upcoming market, of course, is supporting grid infrastructure. So we help infrastructure or TSOs and DSOs to manage grid bottlenecks with, in particular, the Ringo project in France. I stop here because there are many other questions.
Of course, yeah. I mean, it's interesting that last year, we did a webinar together that was on the importance of energy storage systems technology being flexible to respond, to changing market conditions. And even in the year since we've spoken, I think, yeah, a lot of those different market options and applications have opened up, and there's talk in a lot of other regions and, a lot of markets within regions, actually, I think, opening up. Okay, so here's an interesting one from my point of view. Gunther Welzer was asking, which organizations still have experts sitting in front of a real-time monitor and watching data sort of every day? Doesn't that have to be all automatic or unmanned? And if I could just sort of editorialize this one a little bit, like, if we could just maybe ask, to some extent, there needs to be human intervention, I guess. It can't all be automated. So sort of where are we dividing things now between sort of automated and fully remote operations, and where still might we require human intervention? Now, I'm not sure who wants to step in. Maybe Carlos, is this one you could step in and answer for us?
Sure, Andy. I mean, what I would request is if you can expand a little bit on the question, so I provide the better context, if you will.
Yeah, I mean, I guess so. The audience members asking which organizations still have experts sitting in front of a real-time monitor and watching data, and doesn't that have to be automatic? And then my sort of addition to that is, what levels still need to be done by human hands, and what can we do? What can be fully automated, I guess.
So excellent question, right? And as we progress with anomaly detection algorithms and predictive algorithms and all of that, the necessity of having a human being be in front of the screen is less and less needed, right? So the whole point of this is to be able to identify these anomalies through algorithms that will raise alerts that then will notify a human being to take some action, right? And that's what this whole thing is all about, is not have somebody sitting in front of the screen 24/7, but rather have a way to be notified and then go in and look and troubleshoot and then decide what actions to take remotely, right? That's the whole idea behind this. Now, after the troubleshooting, certainly there may be scenarios that some field intervention will be required, and the process will follow, right? But the point is to use algorithms to be able to generate these alerts and avoid having somebody to be permanently monitoring.
Right, of course. And we had another question in here, and forgive me, I've not got the questioner's name in front of me, but they were asking about battery energy storage systems that might be delivered in remote areas where perhaps the internet connectivity isn't sort of full-time or isn't particularly strong. And also there's another questioner, Manfred, who's asking about the Saft's interoperability in relation to microgrid control systems. I guess those two questions are sort of related. Is that one that any of our speakers can run with a little bit?
For the remote, Andy, I can take that. If there's a connectivity concern, whether it's a remote or for some other reason, it could be security reasons, right? The data quality is not going to be lost, right? The data quality is preserved in the system. Now, the only issue is how quickly you can access the data. But if for a remote scenario that impacts connectivity, we can still get the data in a batch mode and do the analyses. However, what's impacted is how quickly you're able to respond, right? As a result of whatever the data is telling you.
Right, okay.
Yeah.
Okay.
If I can give some additional complementary answer to the one given by Carlos, our server is having a pretty big hard disk that allowed us to store a good amount of data for a long time, and it's possible to retrieve the information later on the time. However, it's preferred to get online, but yes, it's a bufferized solution that allow to, even if there is a cut of communication, there is a buffer, and it's always possible to retrieve the data later on the time in an asynchronous way. I think which is very important, this kind of solution, is to add to tag all the logs and events and data with the local timing, which allows to retrieve the data in the cloud and easily put together all information. So it's important to do local timing. It's a good practice. And last, this regarding the remote sites and microgrids. Yes, the system solution can be connected to PMS or microgrid controller, including PSS. Actually, we have a solution for that in order to support microgrid activities. And yes, the interoperability is important depending on the communication standard established. But yes, it's a great point, a great question.
Absolutely, thanks. And by the way, everyone, that was Gerardo, who's one of the experts at Saft, who's very kindly stepping in with the Q&A. So I guess we're running out of time rapidly, but we'll try and squeeze in two more quick questions if we're allowed, I think. So Gregoire was asking if Saft provides customer access to data and the KPIs dashboard for the operations and performance monitoring.
So I can take that one as well, Andy.
Sure.
Gregoire, yeah, we do. There should be, as part of the dashboard, different levels of access, and to allow our customers to see their operation KPIs is available.
Sure. And I noticed, we did want to discuss the polls a little bit, and, I think we're just trying to fit this in right at the end. But Stefan's quick question for you, our resident software expert here. Someone noted that although, you quoted that really good data from Dragos, said 63% of US-based companies had a cybersecurity incident. It was fairly low on the list of responses in terms of the main challenges in response to a poll. Only 14% of respondents said it was the main challenge. So do you think that ESS operators are underestimating cybersecurity? And are there any sort of further recommendations you can make that people should start thinking about today?
Yeah.
Big question, I know, sorry. Yeah.
Good question. Yes, maybe yes, maybe the topic is a little underestimate right now, but the awareness of our industry on the security topic is growing every year. Maybe if we did this same poll 2 years ago, the figures would have been even lower. So hopefully it is progressing. And what we see from our customer is that more and more they are providing us very detailed requirement specification. At 2 years ago, the cybersecurity requirements were maybe two-page document, and now it is 20, 30, more and more detailed and precise. So there is a good progress on that, and it will continue. I'm quite sure that it will become like the safety. It will become potential business killer. So it must be taken into account.
Of course, yeah. And the amount of data that's being collected is going to grow and grow and grow, and the amount of data that's being transmitted will also grow. And obviously, the amount of energy storage that's deployed will grow hugely too. So I guess it's really important to get involved with that side of things now. So,
and indeed, if I may add to this, we do see customers who are very sensitive to this question, in particular utilities who are operating large energy systems, or in particular transmission grid operators, who are very much aware about these risks for their own systems, and they put rather high requirements to us.
Absolutely, absolutely. Well, okay, it's been a really great session. I'd like to thank all of our speakers, and of course to all of you who watched and participated. You will be sent, we had a few questions about this, you will be sent the slides and access to the recording after the webinar. And of course, I'm sure everyone at Saft will be more than happy to help you with any inquiries you might have, either about their specific products or more on the topics in general, so you can learn more about them and how the digitalization can benefit your energy storage system and business. Great, thanks very much, and bye from me. So we had quite a few questions from the audience, a lot of good quality questions. Quite a few of them came in, so we're not going to get time to do all of them, but the most popular question that came from the audience, and this isn't quite really on the digital topic, but if you can steer it towards that direction, I guess that would be great. So Gabriel asked, does Saft produce its own cells in BMS, and where are the cells used by Saft manufactured? And we could also include the second question with that from Thibaut, who said, what is the main battery technology used by Saft in their ESS applications? And perhaps there's something that can be said on the interaction between battery cells and the digital capabilities in that. From you, Michael, perhaps?
Yes, sure. Thank you. So we are a manufacturer of battery cells, so of electrochemistry. By the way, lithium-ion technology and also alkaline batteries and other technologies. Now for ESS, we have supply partnerships with different vendors. And we co-design then from there the modules, and but when it comes to all the controls, and in particular the BMS, these are all genuine in-house Saft developments and productions. And well, as I think we've said, we develop and put together the entire system by ourselves. The technologies we use for ESS is NMC traditionally, and iron phosphate mainly right now.
Absolutely. Yep, sorry. Okay, sure. And the question maybe for our resident software expert, Stefan, from Kyle, and he's asking, asking to confirm if you're transmitting 1 second data to the cloud, and what is the typical bandwidth or data plan requirements of this type of system? And if you'd maybe like to elaborate sort of on the, what the requirements are in terms of data and connectivity, that would be terrific.
Yeah, interesting question. Basically, one battery container, which hosts 2.5 megawatt hours, is generating something like between 1 and 2 gigabytes per month. And it means in terms of bandwidth that you need somewhere between 3 and 5 kilobits per second of bandwidth in uplink. But it is with 1 second data points, but we apply several strategies to optimize this bandwidth. The first one will be to only send new data when it is changed. If the value is still the same, we don't send the data points. And the second one is to compress. The data is compressed before being sent to the cloud, and it is uncompressed when it is ingested in the cloud.
Okay, so there's different strategies to suit, really, I guess. Excellent, excellent. Okay, and there's a question here from audience, from Sean, who asks if the functions or models used are customizable i.e. in collaboration with a customer or a third party? Are these models available for modification to the specific project? I don't know who wants to answer that. Carlos, maybe you might have some views on that. Oh, sorry, I think you're on mute there.
Sorry about that. Yeah, I needed to come off mute. So, yeah, good question, Sean. And yes, Saft is willing to collaborate with our customers, right, on further developing our process for optimizing and improving anything that is related to O&M performance, right? And if especially our the models that we produce with our tool, and if there's any customization that needs to happen to meet the demands, we can certainly have a collaboration effort around that.
Okay, and I'm just wondering, are there any sort of specific examples you can bring out, or do you think that's maybe something that should be discussed on a case-by-case basis with clients?
I would say it's a case-by-case. It depends on the application, Andy. Different customers are going to have different type of services of the battery. For example, the grid, the rate of discharge is one that I can really think of off the top of my head. And certain algorithms are going to be tailored to the application, right? And I think with the expertise that we bring on the manufacturer end of the battery, and the expertise that the customer brings on the operation side, then we can come together and achieve a pretty good, solid collaboration in the further development of these algorithms.
Excellent, excellent. So it sounds like there's some some really interesting conversations to be had on that. Between yourselves, clients, and third parties. Okay, I'd like to note that a lot of our readers, or by no means all of them, have come from or are still involved with the solar industry. And there's a question here from Nacho in the audience, who asks, he says, in solar, the battery energy storage system interconnection design is key to determining the capabilities of the system. What interconnection system is preferred? DC coupled BESS or AC coupled BESS? Now, I guess it might not be from Zaf's question a question of your preference as such, but if there's anything to be said in terms of those different configurations and how they sort of interact with the digital technologies that we've been talking about, perhaps in terms of mapping or what have you, would anyone be keen to take that on?
This is Gerardo speaking. I can take that if that makes sense. There are two possibilities that you mentioned, and it depends on the current use. When it's a new system, and typically the packages are separated between the PV side and the energy storage, the combination of IC connection is the best way, because you isolate perfectly both systems, and it's a typical, let's say 90% of the projects today are performed this way. However, when there is an existing converter and you want to integrate additional batteries in an existing system, the DC coupled system is an interesting one. Also for augmentation, it's a good choice, because we can add in a DC system in parallel another generation or different type of battery to the system. So DC coupled is interesting. However, there are some ups and downs, some benefits to consider, but the cost is slightly could be a benefit by using DC coupling, but you lose a little bit of efficiency in terms of conversion, because you are converting twice, DC to DC and DC to AC on a given point of time. If you have a specific case, we can collaborate to calculate what is the total LCOS, and based on that, we can deliver one or another. So we are capable to do both.
Excellent, excellent. Okay, well, we are fast running out of time now, unfortunately. Just before we go, I would like to run through the results of the third and final poll. And the question was, whether you would trust in the information provided by a Saft digital platform. And by far and away, the most popular answer was yes, I trust the quality of Saft data and algorithms, with 50% of respondents. Only 3% said no, they would prefer to have it run by a third-party provider. Although, in fairness, there are still some people who are looking for more information on this. About above 40% saying that they need more information before they can decide, and as yet, they don't know. So I guess, you know, there's a lot to be said for having the manufacturer provider directly doing the data collection, and I'm sure that's something that the guys at Saft will be more than happy to talk with you about if you'd like to follow up on that one. We did have some other good questions in that unfortunately we're not going to have time for, and some that are a little bit into specific areas. So there were some questions on safety, which, you know, is a topic that I'm sure we, both Energy Storage News and Saft, will explore. You know, we will take it very, very seriously. And there's a couple of other questions on specifics. Stefan, I can see one on the Sunspect MISA protocol, to which you're something of an evangelist. So yeah, I hope that can yield some interesting conversations as well. So with all that in mind, I'd like to thank you all for attending, whether you're starting your day or finishing your day. Thank you so much to our panelists. And I guess really, unless anyone's got any sort of concluding messages that they want to finish with, Michael?
Well, let me thank you, Andy, for leading us through these two webinars. And for you, it's really the end of the day or nearly the beginning of the next one. So thank you very much for keeping us up and for moderating this panel. Thank you to my co-panelists, and of course, thank you to you, the audience, for connecting with us today, for putting forward all the questions. As Andy said, for those questions we were not able to answer in writing or during the session, we will do our best to respond to you directly by mail. And in any case, we hope we keep in contact. Again, you will have access to the slides, you can to the recording as well, and of course you can always and we will be very happy if you contact us directly with further questions, inquiries, or suggestions. With this, thank you very much for today, and bye-bye.